So I'm Tony Reina. I'm from EHTEL. That's my disclosure. And I'm going to be talking about some research that I do in something called federated learning. Um, I really like the opportunity to speak here at this session, particularly because I want to highlight guaranteeing trust as the overarching concept here. And that's really what my talk is going to be about, is trying to find technology uses that can guarantee that trust. So that's what I hope that you get out of this talk. So as we talked about creating this European data space, and you can even think about it as a world kind of data space, the problem that we see, that in my research I see, is the idea of data silos. And so going to kind of my specific research, I'm dealing with healthcare artificial intelligence. And so when I talk about things like models, I'm talking about algorithms that help to, let's say, identify, in the cases that I do, brain tumors from MR scans. Um, what we really want to do, and what seems to be a truism, is that we're actually taking these algorithms and training them or teaching them how to detect gliomal tumors from MRs by showing it lots of data. And the more data that we have, the better those models end up performing. Um, Obviously, with data silos, the issue is that we really can't get access to a lot of this data. And this is for lots of different reasons. Privacy and legality are probably the two biggest ones you think about immediately. In the US, it's HIPAA laws, health privacy laws, GDPR in the EU, um, local regulations, all sorts of even hospital level regulations of getting this. Um, Also, data is sometimes too valuable. There's this catchphrase in AI that data is the new oil. And so we say, if you don't know how much your oil is worth, you might not even want to put your oil out there. I know that's something we've discussed here in the session and with the EHTEL conference, is how do we encourage people to kind of contribute data. And then finally, even if you get past all of that, data is just too large to transmit sometimes. So if you've got petabytes or exabytes or zettabytes of data, it's really difficult to put it all in kind of one centralized place and be able to train this kind of these super models. And so I often say, so what's the point of this? I mean, why does this really matter? Well, if you have a model that is trained on data in Munich, and it's not performing very well in Madrid or in Manchester or in Mumbai or in Manhattan, then maybe that model that forms great in Munich really isn't doing what you think it's going to do. And there are kind of an inherent bias in that. So maybe that's not the model you want. You really want a model that is generalizable enough that it should work everywhere if it's really learning something about, for example, brain tumors. So federated learning is this concept that Google coined, and they came up with this idea because in their case, the model, the algorithm that they were training was using their cell phones. So you have, your cell phone here, and you're trying to text. So let's say I'm texting my wife, and I say, "Honey, I'm going to the store. Would you like me to pick up blank?" And so, they're trying to predict what I'm trying to type, and they're trying to help me out and say, I think the next thing that Tony's going to type is milk or eggs or whatever, and not cat or dog. Um, Google realized that it wouldn't be very private of them, privacy preserving of them, to actually read my texts. So what they did is they said, well, let's do this concept that we're calling federated learning, where instead of having Tony and John and Klaus and Luke send their text up to Google into kind of some centralized thing, we can keep the silos. Everybody can keep their own data. We're just really going to pass around the model. We're going to pass the algorithm around. And so the data never leaves. I keep my data, Google never sees it. John keeps her data, Google never sees it. But we're able to get a model that correctly predicts the right thing and is unbiased, will work well for all of the participants. So this sounds fantastic. It sounds like, okay, we're done. Well, until we start looking at this and we're like, this is really great. This is exactly kind of the way we think we can go toward keeping privacy. But we also said, well, what are the attack vectors? This is now a new kind of way of doing things. how can people could potentially attack the system? And you actually can attack these systems. And so this is one that I kind of get up my soapbox and talk about. And I think we have some ways of using technology to work around this to guarantee this trust. But let me just talk about two really quickly. You're moving the model around now, you're moving this algorithm around. And so people now, you're inherently trusting them to do the right thing. And again, it's a trust type of thing. And so you might have some individuals who try to poison the model, meaning that you're training this model, you're developing this algorithm, and they might actually send you false updates. You're asking them to do a workload and send you back the results. They might just send you some random results. If they do that, you never will actually converge on it, and so your cell phone will predict cat instead of milk when you're saying I'm going to the store and getting me. You can have somebody, and at that point it's like, well, what's the point of doing this whole thing if I'm never going to like converge on a model that actually works? And you will have people that just want to spoil the system this way and poison the model. Even more nefarious, I can actually, and this is both of these have been shown in literature, these sorts of attacks, I can actually recover training data. So if I'm really nefarious, I can actually create updates that I send back. I can create responses back that will actually cause me to learn more about people who are behaving trustworthy and getting their data. And so in this case, the academic was able to show that someone could steal a cell phone image from a player in the Federation that was behaving acceptably, that was trustworthy, and the untrustworthy one was able to actually steal the image. So even though the data is not leaving, the model, the algorithm that's leaving learns things about this data. And so if we don't have trust in the system, we open ourselves up to these sorts of attacks. So the last slide is just, I'm looking at, this is kind of the research that we've been doing. And this is something called a trusted execution environment. We call it SGX. There are many different flavors of this in tech. And it's not just Intel that has these sorts of things, but people are coming up with these sorts of ideas. The basic idea behind a trusted execution environment, and I've got a link here to a video you can see at the recent conference that was last month, where we're training a model that does brain tumor segmentation using AI, using a deep learning model. And we're able to do it within this trusted execution environment. And what that means is it's a space on the computer where unless you have the cryptographic key, you can't get in and fool with it. So I can't actually see what's going on. I can run something on John's computer or on Luke's computer, and Luke or John can't actually get in and fool with what I've asked them to do. I've asked them to do it. They've agreed to do it. They have no ability to change what I've asked them to do. And even more importantly, there's an aspect of attestation, which just means that they have to show a receipt that they could have only have gotten if they had run the workload I asked them to run. So they have to prove that they've done the work that I've asked them to do. And if you start to add these things in, then the attacks that I talked about start to fall away. It starts to become very, very hard to do those because the people that are participating in the Federation can't actually attack the algorithm and can't somehow spoof what's happening in the Federation. They have to actually show with technology that they're trustworthy and that they've done the tasks that I've asked them to do. So that's where I think this field is going, and I think these sorts of technologies, this trusted execution environment, is something that I think will be applicable to a lot of these cases where we want to have an inherent trust, but we don't just want to have legal or some sort of regulatory regulations in place. We actually want to have some way of automating that trust. And that's all I have. And thank you very much for your time.